Okay, so this is a talk on the mathematics behind retiring early. And so this is kind of a fun topic and also is an application of mathematics because it's not entirely theoretical in nature. So before we start talking about complicated assumptions or things like that, let's start by looking at assumptions that are much simpler than what we would face in reality. That way we can get an idea of what the variables might be and what kind of results we might expect. Okay. So for saving for retirement, we might think of the whole life of a person as consisting of multiple phases. Okay? So, okay, something like this. This is maybe the birth of a person, and this might be the death of a person. Okay? Moving from left to right. Okay? So when a person is born, they might have a childhood, and then a period of education, then a period of work, and then a period where they are not working, which might be called retirement. Okay, so if one is working, one has an income, hopefully. So we might denote that income by a letter, I. All right. And then each year, you might save a certain fraction of that income. Okay? So at this stage, we're being very, very simple. Okay? So we're not dealing with inflation. We're not dealing with governments. Okay? We're assuming your income is fixed over time, which is not a realistic assumption. And we're assuming that your savings rate is constant over time, which is also not a realistic assumption. Okay? So then later we can make things more realistic once we have some idea of what we're doing. Okay? So S will be the fraction of income saved. Okay? So it could be 1/10, it could be 1/20th, it could be a third, it's just some fraction. Okay? Great. And so if we are working for a certain number of years, okay, let's denote that by capital T for the amount of time. Okay? T equals the time worked in years. Okay, so again, in this case, things are still very simple. So there's no banks. Okay, there's no interest. All right, we're just imagining maybe every year you have a bar of gold you put under your bed. Okay, all right. So then how much do we save over our period of work? Well, in 1 year, you save S times I. Okay? If S is 1/10, then you've saved 1/10 of your income that year. So that's the correct result. Okay? And then if we work for T years, we get that savings multiplied by T. So if we work for 40 years at 1/10 of our income and savings, we end up with 4 times our annual salary saved at the end of 40 years. Okay? So these are all mathematically correct results. Okay? So this is the amount saved for retirement. Okay? So remember here, there is no interest on the savings. Okay? No taxes, etc. Okay? Just the simplest case. All right? And then when you're retired, okay, each year you want to withdraw some of the money you've saved to pay your living expenses. All right? So now this is tricky. What should we withdraw? Well, it's not entirely clear. But you'll have to withdraw something to live on. And since I don't know how much yet, I'll just denote that by the letter W for the fraction that you withdraw at the beginning. OK? So keep in mind that the equation I'm going to write is just for the initial year of retirement. OK? Because the amount of money you have will change because you withdraw. And that will change the fraction of the remaining money that you have to withdraw in the subsequent years. For example, if I start out with 10 bars of gold, and the first year I take 2 bars of gold to pay my expenses, okay, that's 2/10 of my money that I had to pay for expenses that year. But if the next year, if my expenses are the same, then I need to take 2 more bars of gold. But that, because I only had 8 bars of gold left after the first year, it's a larger percentage of my savings that I am forced to withdraw. Okay? So that's why this equation will just be for the first year of retirement. Okay? When you are first retiring, you take a certain fraction of your savings, which will be W, the withdrawal fraction, okay? And that equals your living expenses. But what are your living expenses? Okay? So this is withdrawal fraction. Okay, these are living expenses. But what are those? Well, I'm going to assume that your savings rate is such that your living expenses are what you aren't saving. Okay? This is a simplified assumption. So if I was saving a fraction s of my income before and my living expenses are the same, which is an assumption, then it should be 1 minus s should be the fraction that was expenses. So a good rough guess for my expenses would be the old income minus s times that income. The part that I don't save must be the part that was expended on my expenses. Okay? And so this is the simplest retirement equation I could come up with. Okay? Based on very simple assumptions. All right? So is this telling us anything? I think it is telling us a lot. In particular, I is everywhere. Your income is everywhere. But notice it appears to the same power everywhere. So I could divide it out everywhere. Okay? So what would that mean? That would mean that the withdrawal rate times the time times the savings is just equal to 1 minus s. Okay? Because I just took everywhere division by I. So this is a very important observation, and it's a very simple one, that how long it takes you to retire is not dependent on income, but rather on the proportion of your income that you save. Which, of course, if you have more income, you could save more, you see. So it's not like income isn't relevant. It's just that the most important factor is savings rate. So making more money is not necessarily a bad thing. It just means you could save more. But the savings rate is what matters. So if you are very frugal and don't waste money, you might be able to retire faster than someone who makes a lot of income but also spends it very, very rapidly. Okay. So now the trouble is, like I said before, that this is only for the first year of retirement. Okay? If I have less money, then I have to withdraw a larger and larger fraction every year in order to pay my living expenses because they are the same. But the amount of money I have saved decreases. So this means after a certain number of years, I will run out of money, and then I will not be able to pay my living expenses. So, you know, before the 19th century, people did not have a very long lifespan, or at least they were believed to have a shorter lifespan than we do now. Okay? So this possibility of dying before you run out of money was not always the biggest concern. You were more like, I mean, wait, did I say it in reverse? Sorry. Running out of money before dying wasn't always your biggest concern. Usually your biggest concern was dying before you run out of money. Yes. Okay. Dying was usually going to come up sooner or later. Okay. But now that people live a little longer, they need to think a little bit more about the possibility of running out of their savings before they die. Okay. Then how to choose the time to retire? How to choose the withdrawal rate? Okay. Well, if you're not sure how long you're going to live, there's no solution to this problem. Okay? Because if you live long enough, you'll run out of savings, and then you'll run out of money. Okay? If you can't tell how long you're going to live, which most of us don't know, we certainly can't solve this problem. Okay? But fortunately, we don't live in a world where there is no interest. So, if our money is in fact earning money, there may be a solution to this problem. It may be possible to have enough money to where you can live off of the interest regardless of how long you live. The trouble is, interest rates do go up and down, okay, but we could assume for simplicity that the interest rate is something, and then solve the problem for that fixed rate. Okay, so then what we need is to have R. Okay, so R is going to be the rate of interest. Okay, so I'm pretending that there's some super fantastic bank, okay, which gives you interest that's more than the rate of inflation. All right, because obviously there's going to be inflation, which we didn't talk about over here. Okay, if your dollar earns 5 cents, but then $1.05 a year later purchases less food for you than $1 did last year, you're really losing money. That is, you have less purchasing power. So ultimately, this is only useful if your rate of interest is higher than the rate of inflation. Okay, so this is going to be the rate of interest after inflation. So that is, if your interest rate was 3% and inflation was 2%, this number would be 1%. Okay, so it's the amount by which your interest is greater than inflation. Okay, so of course, life is complicated. Sometimes in order to procure an interest rate that is significantly higher than inflation, you must take risk. But then if you take risk, it is not like a bank account. So you see our assumptions are simplistic, idealistic, not based entirely in reality. But they could provide a guide to get estimates on how long to expect for these sorts of things. Okay. So we have this interest rate. So let's solve the W problem. Okay? All right? I'm going to make a simplified assumption that each year your bank only pays you interest one time per year. That way, the calculations will not be complicated. And I'm going to assume later that when we work, that we're only going to put our savings into the bank once a year. That will also make the calculations less complicated than if we put money into the bank once per month. Okay? Obviously, that will throw off our answer a tiny bit, but it'll give us the right order of magnitude. Okay, so imagine I'm going to solve the W problem. All right, so we retire with A dollars. Okay, A is the amount of dollars I have. All right, well, then at the beginning, of the first year of retirement, I withdraw money to pay for my living expenses for the year. Okay, so then I have So I have 1 minus W times A dollars. Because W is the fraction of money that I withdrew. So if I withdrew 5% of my money, I would have 95% of my money left at the beginning of the year. Okay? Then, over the course of that year, I will earn interest on the remaining savings. Okay? So, at the end of the year, I have those original savings, okay, plus interest. Okay? So the interest might be, I get 5% of that money added to it, say, if R was 5%. So it'll be R times that amount. So I end up getting 1 minus W times A times 1 plus R. So did you follow that? This was the amount of money I had at the beginning of the year after withdrawing for expenses. Okay. Then at the end of the year, I have that amount of savings plus R% of it is added to my savings from interest paid to me by the bank. Then I factored out 1 minus W from both terms, and I factored out A from both terms, and that left me with 1 plus R on the right. And so this is the amount of money I have at the end of the year. Okay. So if this amount is less than A, then next year I will have to withdraw more money to pay my same living expenses, a larger percentage of the money, that is. Okay? But if this is greater than or equal to A, then I have no trouble at all. Okay? Because I can withdraw the same percentage or a smaller percentage of my money. So then we have sustainable retirement. If this amount is greater than or equal to A. If the amount of money I had after 1 year of retirement is greater than or equal to my original amount of money saved, then I consider that retirement to be sustainable. Okay, but you'll notice here that A is a factor on both sides of this equation. So whether your retirement is sustainable or not depends only on the rate at which you withdraw your money and the interest rate, and not on how much you saved. Although keep in mind that if you don't save enough, you won't be able to withdraw the amount that you hope for. Okay, so this is true, is equivalent to saying, so this is just my symbol for equivalent, okay, so I don't have to write E, Q, U, I, V, A, L, E, N, T, all right, to this condition. Okay, we want to solve for W to find out what is a safe amount to withdraw each year from our retirement savings. Okay, so we can distribute this term over here. So we have 1 plus R minus W 1 plus R. All right, we're trying to solve for W. So I'm going to subtract 1 from both sides. Okay, now I'm going to add this to both sides. And now I'm going to divide both sides by 1 plus R. And this is my result, that a sustainable rate of withdrawal from your savings for retirement years, it's sustainable if it's less than or equal to the rate of interest divided by 1 plus the rate of interest. Okay, so this is a very nifty discovery here. And this is the beginning of where retirement theory is developed. Once you know that under certain conditions you can safely withdraw some money and still have enough savings to go on, it means you can have a sustainable retirement. So this is a pretty important discovery. So, okay. So what does this mean in practical terms? Well, say that you're invested in the stock market, okay, over a very long period of time, say 30 or 40 years. So over a single month or a single year, the stock market could behave very erratically. In a single year, you could lose 30% of your money or gain 30% of your money. It's possible, okay? But there are no 30-year periods where an investment has lost money in the stock market. In fact, over 30-year periods, the stock market always returns between 6 to 12%. Okay, over 30 years. And so I'm making a lot of assumptions in discussing this. I'm talking about the US stock market. I'm talking about some appropriate index that measures the aggregate behavior of the stock market. So say something like the S&P 500, okay, which is a selection of 500 companies, blah, blah, blah. Okay, I'm not talking about the precise details, but the point is that over 30-year periods, the stock market has never returned less than 6%, say. Okay, but of course, the future, we don't know for certain how it will work. All right. But anyway, there's going to be inflation, so we shouldn't just use these numbers as they are. Okay, inflation varied very much. So say you have about 7%, okay, and there's 2% inflation. Then R, the rate of interest after inflation, will be 5%. Okay, and therefore the maximum withdrawal rate should be 0.05 over 1 plus 0.05. Like that. You should withdraw at most 5% divided by 1 plus 5%. And so that's about 0.0476. Okay. So if you're expecting 5% returns above inflation in your saving years, then you should expect to withdraw from your savings at most 4.76% of the amount you saved each year. Okay? So that's really cool. We had an assumption, and we deduced this consequence that of a certain amount we can withdraw safely and no more. That's pretty cool. We got these specific numbers. All right? So you can have fun with this. Okay? You could imagine, well, what if the stock market doesn't do as well? What if it's 4%? Then you can calculate the safe withdrawal rate in that case. What if it does really well? What if it returns 10%? Okay, well then you can calculate the safe withdrawal rate in that case. So you can get a range of withdrawal rates that seem reasonable to you. Okay? So you can be more conservative or more optimistic, and you can just adjust things. So it's very nice to get these exact numbers at the end. Okay. So that's the case of retirement. Okay? If you have a sustainable retirement, you don't have to worry about money during this period at all. Okay? Now, the only question is, how much do I need to save in order to be able to have enough money that I can withdraw such a small amount each year? Okay. So that's the next part of the talk. All right, so I'm going to erase this. And by the way, the stock market can obviously go down significantly in a single year. Okay? If the value of your savings goes down significantly, what used to be 4% of your savings might become a larger percent, right? If my money is temporarily worth half what it used to be, and I need to withdraw that same amount, it becomes a larger percent of my savings. So in practice, we don't use this full number to withdraw. We withdraw slightly less than this number. Okay? That way, when the stock market is temporarily crazy, we can withdraw a little more than the amount, a larger percentage than we typically withdraw, and we'll still have enough to live on. So oftentimes people recommend 4%. If R is 5%, maybe W should be 4%. You should generally round down because of unexpected things that could happen temporarily on a day that you need to withdraw some money. Okay. So even though we have these simple assumptions, and this works for these simple assumptions, the reality is that the stock market is slightly more complex than a bank account. And therefore, you always need to withdraw slightly less than this simple model predicts. Okay, so just a caveat on that. I don't want you coming to me in 30 years and saying, but Sam, my withdrawal rate was less than or equal to R over R plus R over 1 plus R. You generally need to do less than the maximum amount. Okay, so S is our sustainable savings rate. Okay. All right. T is going to be number of years of saving. Okay. R is going to be our interest rate after inflation. This is just a review. You've probably already written these things down. Okay, and W is our withdrawal rate. Okay, so to get some idea of what's going on, let's make a little chart. Okay, the chart on the left will put the amount of years we've been saving, and on the right will be the amount of money we have after that many years. And once the amount of money we've saved is such that the withdrawal percentage gives us enough money, then we're ready to retire. Okay, so here, time in years, okay, and money. Okay, so initially, time 0. That might be the first time you get a job that gives you income, whenever that might be. That could be at age 22. It could be at age 18. Could be at age 15. Could be age 30. It kind of depends. All right? Now, how much money do you have when you first get a job? Well, in this model, we can just pretend that's 0. Okay? But this assumption could be altered very easily. I could assume that I have a negative amount of money here. Say I have a debt, a loan that I took out to pay for some advanced education. Okay? Or it could be I have positive money. Maybe my grandfather just died and he left me $5,000. Okay? So it could be a positive amount. All right? But this is easily changed. And for simplicity, I'll just start it out at 0 because why not? Okay. So then, now I've worked for 1 year. Okay? How much money do I save? So remember, my simple assumption here is that the bank pays me interest only once per year, and I put in money only once per year, because that leads to the simplest calculations. Okay? So you know everything should really be multiplied by our income, but remember we found out earlier that we could divide out by the income, and it makes everything simpler. So instead of dealing with money, I'll deal with money as a multiple of income. As a multiple of income. So I've saved my savings rate as a multiple of income. That's what I've saved after 1 year. Okay. Now after 2 years, the bank has given me my first interest payment on this. Okay. So I have the savings rate plus the interest rate times the amount that I saved. Okay? Plus the amount that I saved during the second year. Does that make sense? So I had the money I saved the first year, plus the interest I got from the bank on that, then the money I saved the second year. Okay, any questions about that? Because this is obviously an important step as we're increasing the number of years and understanding the patterns. So here we can factor out S from this term, and it becomes S times 1 plus R plus S. Okay? Now you might ask, Sam, why did you write it that way? By the way, my name's Sam. I don't know if I introduced myself. Hi. I probably introduced myself earlier, but I'm very forgetful. Okay. I like to group the things that came from with the other things from that year. Okay? So this money originated in year 1, and this came from that thing in year 1. That's why I've grouped these two together. Okay? I like to group the things that originated from year 1 together. All right? So then how about after 3 years, what do we have? Well, we had that money that came from year 1 plus the interest on that money plus the money from year 2, plus the interest on that money, plus our savings from year 3. Okay. So already things are getting pretty complicated. Okay? But these two terms both have s and 1 plus r, so we can factor out s and 1 plus r. And we're left with 1 plus r here. Because if we factor s and 1 plus r from this, we get 1. Factoring out s and 1 plus r from this, we get r. Okay? Then for the second one, we can factor out s, and we just get 1 plus r. And then the last one is just we leave it alone as s. Okay? So there's actually a kind of pattern here developing. This 1 plus r times 1 plus r is 1 plus r squared. Okay. So what if I continue to year 4? All of these would be multiplied by 1 plus r as a result of the interest. Then I would add s. So, skipping the details, we get s 1 plus r cubed plus s 1 plus r squared plus s 1 plus r plus s. OK. Let's assume that the pattern continues. We could prove it, but I'm just going to assume that the pattern continues. But you can prove that the pattern continues like this. And so we end up with the following. Okay, we have, at time t, we have s times 1 plus r to the t minus 1. Because notice this was 4 and this was 3. So this first exponent should be 1 less than the number of years. All right? Plus s times 1 plus r to the t minus 2, plus and so on, plus s times 1 plus r plus s. Okay? That's the general pattern we're seeing. Okay? And this is the amount of money we have. So this is pretty complicated. So before I move on to talking about using the withdrawal rate, how about I talk about simplifying this? So we can factor out s from all of these terms. So we get 1 plus r to the t minus 1 plus 1 plus r to the t minus 2 plus and so on plus 1 plus r plus 1. Great. OK. Now I'm going to use a trick to simplify this dramatically. OK? The trick is a little strange, so bear with me for a moment or two. All right? So first of all, I'm going to abbreviate this long thing by a single letter. OK? So q, this quantity q, will just be this. OK? I want to somehow simplify the right-hand side. All right? Well, you notice each term, you go to the next term by dividing by 1 plus r as you move to the right. So if I multiplied q by 1 plus r, it would be like shifting each of these terms to the left. So 1 plus r times q equals 1 plus r to the t plus 1 plus r to the t minus 1 plus and so on plus 1 plus r squared plus 1 plus r. OK? But you notice now q and 1 plus r times q have a lot of terms in common. So if I subtract this one from that one, I end up with a very simple expression. 1 plus rq minus q equals 1 plus r to the t, but then these all cancel, and we're just left with a minus 1. Okay? So now on the left side, I can factor out q. Okay, I just factored out q on the left. And then 1 plus r minus 1, that's just r. So I end up with rq equals 1 plus r to the t minus 1. And so in the end, I find the following. That after t years, I have savings of s times q, but q is 1 plus r to the t minus 1 divided by r. So it's s times q, and we can find q by dividing this right side by r. OK. So now we can retire when we apply the withdrawal rate to our savings. Okay, so when it might be 4%, say, when 4% of our savings is greater than or equal to our expenses, we can retire. Okay, so retirement, remember we said that our savings rate was sustainable. That means that the non-savings, those expenses are sustainable. Okay, so the expenses we need are 1 minus r. Okay, remember it's our income minus the savings times income, but remember divided out by income, so it's just 1 minus r. Okay, so t is the number of years to retirement. The smallest number of years to retirement is the first time that the left side is greater than or equal to the right side. The first time it's greater than or equal to it is the first time it's equal to it. Okay, so t equals number of years to retirement when w times s times 1 plus r to the t minus 1 over r equals 1 minus r. Okay? So this is simply assuming that you retire as soon as you have enough money to retire. Okay? Obviously, you could, change this to have more money than you need to retire. You can adjust all of these assumptions. Okay? But this is probably the simplest equation that captures the relevant ideas. Okay, so now we could have fun with this. Okay, we could put in some reasonable numbers for these different quantities and derive the other quantities. Okay, so if we assume we know withdrawal rate and savings and interest rate, we could calculate t by just solving the equation for t. All right? Or say we knew the withdrawal rate and the interest rate and the number of years to our retirement, then we could calculate s, what our savings rate needs to be in order to retire at that time. Okay. So then, assuming we know when we want to retire, we can calculate how much we need to save in order to retire at that time. Okay? So assuming we know R, you could say that R would be 5%, for example. Okay? Sometimes the stock market returns less than that over a long period, but as a rough guess, we would say approximately 5%. Okay? And withdrawal rate, we could say that's 4%. Okay? And what else do we need? T. Okay. Well, At what age would you like to retire? We can calculate the savings rate now. What age would you like to retire at? You can name any age you like. 120, 42, any age. 5 years old? OK, that's hard because I don't know a lot of 5-year-old people that have income. So, OK, 5 years from now? All right, OK. So say you want to retire in 5 years. All right. Then we can solve for S to find out how much of your income you need to save each year in order to retire in 5 years. OK? So now we know R, we know T, we know, oops, this should have been an S here. Oh, no, right? The expenses are 1 minus your savings, not 1 minus the interest rate. The interest rate doesn't determine how much living costs. OK, yeah. So now we can solve for S here. OK? So we have S. OK, so we have 0.04, that's W, times S, times 1 plus R, so that's 1.05. And we're going to do 5 years. OK, minus 1 over R equals 1 minus S. OK, I plugged in this value for W, I plugged in this value for R, and I plugged in this value for T. So now there's only one variable left, and you can solve for the savings rate you need in order to retire in 5 years. OK, so this is algebra, all right? And this is something we can do. So we could add S to both sides, and we end up with 1 plus 0.04, 1.05 to the fifth, minus 1 over 0.05. So you see what I did? I added S to both sides, and then I factored out S. OK, so I hope you were able to follow that calculation. All right? So I factored out S from this, and I was left with this. Then I added S to both sides. That gave me 1 additional S, and I have 1. So now I end up with the following. I just divide both sides by the thing next to S. So S equals 1 over 1 plus 0.04 times 1.05 to the fifth minus 1 over 0.05. OK? And what do we get as the answer? We get that, let's see. I don't know the answer. I'll ask Google. Let's see. So we have 1 over 1 plus 0.04 times. OK, you know what? I think it'll take me a long time to type these numbers into Google. But I made a little chart based on retirement age rather than the number of years to save. And so I'll put the answer for a few years that are close to 5, because I didn't write down 5. OK, so here. So maybe someone can type this into Google or their calculator to find out. What? OK, thank you. OK, great. So I'm going to assume here that t equals 0 corresponds to, say, age 22, because many people graduate with a bachelor's degree around age 22. And then I have t here, and the S, the savings rate that's needed. OK, so all I've done here is for each value of t I'm going to put, I just solved for S in each case. OK, but I didn't do 5. That's why Junichi is going to do that for us. All right, So when t is, say, 58, 58 plus 22 is 80. So this would be retiring at 80. Okay, then I found the S to be about 0.07. Okay, now you might say, doesn't that seem a little high? Well, remember, I'm assuming here, I'm not assuming Social Security, right? I'm not assuming any income from insurance, or Medicare, anything complicated like that. Okay, so in reality, someone could save less than this in the United States and still be all right because of various social safety nets. However, if your savings was the only source of your income in retirement, then 7% would be needed in order to retire at age 80. Okay, that's assuming they want a sustainable retirement. Okay, obviously, if you didn't require a sustainable retirement, like you said, I know for sure I will die by 100, then you could probably save a little less and you'd be fine. Okay, but who knows what the future holds? It's hard to say for certain. All right, then say t is 53. That would mean retiring at 75. Then you'd obviously need to save a little more, 9%. Okay, according to our calculations, which remember are based on very simplified assumptions. Okay, then what if you wanted to retire at 70? Then we'd need to save 12% to the nearest percent. I've rounded in each of these. Okay, what if we want to retire at age 65? That's the traditional retirement age in the United States. Then you have to save 15%. Okay? So if you hear the advice, you should save at least 15% of your income for retirement, this is where it comes from. Because the traditional retirement age in the United States is 65, and our equation tells us that we would need to save 15% in order to power that retirement.
For 5, it's 81.9%.
Wow, okay. Thank you. So, if you want to retire in 5 years and you have an income and your savings rate is sustainable, okay, then if your sustainable savings rate is at least 81.9%, you can retire in 5 years, according to Junichi. Very cool. So that means that your income is so high, or you are so frugal, that the remaining 18.1% is enough to pay for all expenses in every year of working and retirement. Okay, that's hard to do because people typically advise you to spend 30% of your money on housing. Okay, if you're doing that, then this is not possible. But maybe if you get enough roommates, you could do this. I don't know. But anyway, if there's any age you want to retire, this formula will tell you roughly what savings rate you would need. Okay? On the other hand, if you're working on Wall Street and you're paid $1 million every year, maybe this is a sustainable rate, because 18.1% of $1 million is $181,000, and I think most people could easily live on that kind of money each year. So it all depends on your relative position in society. Kind of fun to play with these numbers. Okay, so I did have a few other things on my chart. So what if you want to retire at age 55? Then you'd want to save 24% of your income. If you want to retire at age 45, you'd want to save 38% of your income. If you want to retire at age 35, then you'd want to save 58.5% of your income. If you want to retire at 25, you'd have to save 89% of your income. Okay, that's a lot tougher to do than the one on the left. Okay, every time, so you're saying 11% of your income is enough for all your expenses. That's pretty difficult. I don't know anyone who can do that unless they are very, very rich to begin with. But fun to think about. So anyway, and obviously, if you want to retire at 22, then that would mean that you want to retire after 0 years of working. So in that case, you would need to have a sustainable savings rate of 100%. That would mean that you just live for free somehow. Okay? So that would happen if, say, you live in a country with no income and no taxes, and you're able to grow all of your food yourself and also find all the seeds with which to grow that food, and are able to collect sufficient rain so that that food actually, grows from plants into things to eat. Or you have a parent who pays for everything for you, and your parents are very rich, and your parents will live longer than you. Then maybe that would be sustainable. But anyway, these answers all have meaning, even if that meaning is stupid. Okay, so this is a lot of fun. You can play around with this. Let's see. But if you want to retire at some earlier age, the recipe is right in front of you. So the information is there if you choose to make use of it, or to give advice to your parents. All right, so that's it for this portion of the talk. I do want to mention one other thing, though, that's pretty important, and that is that there's a situation that happens in which you don't want to be putting money aside for retirement. That is the situation in which, for some reason or another, you have debt with an interest rate on that debt that is higher than R. Okay? If you have any debt, with the interest rate higher than R, then that means it's not making sense for you to put that money and get an interest rate of R on that money. Because if you paid off using your savings from the year, if you instead put it towards paying down that debt, that means you don't have to pay that high interest rate anymore. So you're doing better by not paying that high interest rate than if you were getting that stock income. So anytime you have debt with an interest rate higher than your rate of money on your savings, then it makes sense to pay off that debt first. Okay? And so you can derive a similar but different equation for paying off debt. Okay? It's slightly different because every time you reduce that debt, that reduces the amount of interest you have to pay the next year. And so your savings rate changes each year, okay, getting higher because the amount of your money that's paid to interest is less each year. Okay? So that is a different equation, and it's not too much more complicated, but I don't quite have enough time to derive that equation in full. So if you're interested, you can talk to me about it later. My email address here is sjf370@nyu.edu. And now I think it's time for lunch, so thank you very much for attending my talk.